Hi everyone, this is Mrs. Musoff. One of the great things about conic sections, in my opinion, is that there are a lot of applications for it. So we're going to be seeing a couple of them today. One of my favorite is from that movie, Hidden Figures, where they're talking about trying to get somebody out of space, which is trying to change an elliptical orbit into a parabolic orbit so that he comes back. Kind of an interesting note, just thought I'd show you that. But anyway, today we are going to talk about ellipses, so that's why I brought that up. An ellipse is just a set of points in a plane, the sum of whose distance from two fixed points, which we call the focus points or foci, is constant. So just to kind of give you the technical definition, most of these conic sections, their definitions do have to do with the focus points or the foci, and that's why we are so that's why we emphasize them so much, because they are important. They relate to the definition of these shapes, and so that is where the definition of an ellipse comes from, those focus points, those foci. And there are basically three key characteristics when it comes to an ellipse. There's the center, the vertices, there are two of them, and then there are two foci instead of just one. And when we talk about an ellipse, this is the general shape we're talking about, what you see down here. The center, we're going to stick with on the origin for now. Two vertices, and those should be the points that create kind of the edge of your ellipse, but the ones that are farthest out. So the vertices should be like, technically some people think of these 2 points as vertices or co-vertices, but they're not. The vertices should be the bigger ones. So that's how you can tell the difference between kind of the A and the B value. A should be bigger. And then your foci should be on the same axis as your vertices. It should be going in the same direction. So if your vertices are going in the x direction, your foci should be going in the x direction. Remember, an ellipse could be going the opposite way. It could look something like that. Alright, and then these would be your vertices, and your foci would be going in that same direction also. Okay, so just something to keep in mind. Now, the general equation of an ellipse, I'm just going to write it down here. There are two versions, right? One where the vertices are in the x direction, so A, this variable A, is with the x value, whoops, not equals, and Y, the B variable, is with Y. Okay, so that's one version. Or you could have the vertices in the Y direction, which means A is with Y and B is with X. Alright, the nice thing about an ellipse, just some things to notice, it's always going to be addition for an ellipse, and since the order doesn't matter, usually we see X coming before Y. Okay, another thing to notice, ellipses always must equal 1 for it to be in standard form. So standard form of an ellipse is it equaling 1. So if it doesn't equal 1, you got to make it equal 1. And we'll see an example of that when we do some of these problems. Okay, in these formulas, you do see some variables, these new variables. A in a parabola had to do with the focus point, but now it doesn't. A is going to be, A is the distance between the center and the vertex. So A, I call it your vertex distance. Whereas C is going to be your focus distance, the distance from the center and the focus. And you might be asking, well, I don't see a C in here, and that's true. The focus distance doesn't show up in the equations, but there is a common equation that we use with ellipses, and it is this equation right here. B squared is equal to A squared minus C squared. It's similar to Pythagorean, but very different in its key ingredients, so be careful here. And this equation typically will help us to find this B squared value, because B squared is not, the B value is not really a point. We don't call it anything, at least. It doesn't have a name. So typically you're going to be given information about the vertices and the foci, and we're going to have to solve for that B value. So that's why this equation is really important. And I try to remember it as it's always bigger minus smaller. A squared should be bigger than C squared because the vertices are outside of the foci. And it's minus, that's opposite of an ellipse, which is plus. Okay, just some other vocab real quick. This axis here, the longer axis, we refer to that as the major axis, major meaning bigger, and it should be where, sorry, that doesn't look like an R. There we go. It should be where A is, where the bigger value is, however you want to think of it. And the smaller axis does still have a name, and it's called the minor axis. So knowing that vocab is going to become important. Major is the bigger one, that's with A. Minor is the smaller one, and that goes with B. Okay, so let's try a couple examples and see how it goes. Okay, example 1, we've got find the vertices and graph. So one of the key points to remember is that an ellipse must equal 1. Ellipse equal 1. So if you see that it doesn't, try to think back to what we talked about with vectors. If you want something to equal 1, you just divide it by that number. So I want it to equal 1 and it equals 9 right now. Well, I'm just going to divide everything by 9 then. And that'll put it in standard form. So then I have x squared over 9. I'm sorry, not over 9. Because the 9's divide out, that's 1, so it's x squared over 1. Plus y squared divided by 9 equals 1. And so now this right here would be standard form. Okay, in order to graph this, I am going to need the center, so I'm going to start there. There's no shifting, so our center is at the origin. My vertices. So the vertices, you're looking for the bigger number. But remember the equation, those numbers are always squared already. So to get just A or just B, which are your distances, you're going to have to square root those numbers. So for example here, I'm going to look at the bigger number, and I'm going to say, all right, that's A, but it's the square root of that, so A is going to be 3. And since it's below the y variable, it's going to move in the y direction. So my center is at 0, 0, right here, center 0, 0. Well, because A is equal to 3, that means my vertices are going to be 3 away from the center in the y direction. So my vertices will be 0, 3, and 0, negative 3. Or you could write 0, plus or minus 3. That's fine too. So I'm going to move up 1, 2, 3, down 1, 2, 3, and plot some points. Vertex, vertex. Okay. Now, we do need that B value to help us draw the rest of our ellipse. It just doesn't tell us any key characteristics. So I'm going to use this B value here. And it's the square root of that, which is still 1. And it's in the x direction. And I'm just going to use that to graph. So I know 1 in the x direction away from the center. These are going to be points on my parabola. They don't have a name. We don't label them with anything. They're just points on the parabola, so we can graph it correctly. Okay. To graph an ellipse, I mean, right now I can obviously draw it, to the best of my abilities at least. But we do still need one other thing. Whenever you graph an ellipse, the last piece is to find your foci. And to find your foci, we're going to use that equation from up above. B squared equals A squared minus C squared. So I know B squared is that smaller number, so that would be 1. And I know A squared is my bigger number, and that would be 9. And I'm just trying to solve for C squared. So it would be this equation. All right, I would add C squared, subtract the 1. So C squared will be 8, which means C will be plus or minus 2 root 2. So to come up with my focus points, I know they're going to be 2 root 2 away from the center. But make sure you know in what direction. It should always go in the same direction as your vertices, and my vertices are in the y direction. So these will go in the y direction also. So my foci will be 0, up 2 root 2, and 0, down 2 root 2. And you would get those in your calculator, right? You would, oh, there we go, sorry. Do 2 times the square root of 2, or just the square root of 8. You would get the decimal, and that way I'd know how to plot them. So they're about 2.8 away from the center. So 1, 2, very close to your vertex. 1, 2, very close. And then I'll just label it. That's my focus, and that's my focus. And that's all there is to it. Okay? So understanding what each piece means, that's going to become really important with an ellipse. All right, let's try a couple examples going backwards. Okay, so in this example it says, find the equation, and it gives us the center, the focus, and the vertex, or one of each at least. So if I know my center, the fact that it's on the origin, I know it's just going to be x squared and y squared on top, no shifting. And then if I know my focus and my vertex, notice how it's the x value that's changing from the center. That tells me that this ellipse is going to be going in the x direction. So A and C are in the x direction. And the reason that's important is because now I know how to write the general form of the equation. If a and c are in the x direction, then a squared will be below x, and b squared will be below y. So I've got my general formula. Okay, now I just need to find these different pieces. A, I should be able to find because that has to do with my vertex. A is the distance the vertex is from the center. Well, my vertex is 4 units from my center. Don't use the negative because it's just a distance, so it's always positive, just 4. And that means my a squared will be 16. So this will turn into x squared divided by 16. The b is trickier because b squared, the only way to calculate that is from that equation we have. B squared equals a squared minus c squared. And I know a is 4, so that should help. But I would also have to know c in order to solve for b. Luckily, we were given the focus. So I know c, because of that focus, is going to be 3, because it's 3 units away from the center. So I can plug that in and solve. So b squared is going to be 16 minus 9, which would be 7. And you could keep going. You could square root it and actually solve for b. But keep in mind, it's b squared that I want in the equation. So I might as well just stop here. And I know then that b squared is 7. And so here's my equation. All right. If I needed to graph it, I could. That's why I drew this here. So some people like to kind of plot those points so that they can make sure they've got everything in the right spot. Feel free. Sometimes your book will ask you to graph it along with the equation. So just pay attention to the directions. All right, let's try another one. So again, writing the equation, we have our focus points at 0, positive 3, and 0, negative 3, and x-intercepts at plus or minus 2. Well, let's start with the skeleton of the equation. My focus, it's moving in the y direction. That means my vertices will also, so A is in the y direction. So I'm going to have this general formula. And I could tell my center was at 0, 0 because it's halfway between the two foci points, focus points. Okay, now my focus, that means C is going to be 3, which is great, but that doesn't help me with my equation. So that's where this x-intercept at plus or minus 2 comes into play. Keep in mind what we have right now. We have a center at 0, 0. We have focus points at 0, positive 3, and 0, negative 3. Remember, focus points aren't actually on the ellipse. They're just part of the graph in terms of what information we need. But now it's telling me I have x-intercepts at plus or minus 2 right here. Well, if those are x-intercepts, that means those are on the graph, which means what they're really giving us here is the distance from the center to those extra points. And that distance we call b. So this right here is going to be our b value, which means that I know a piece of my equation. I know this piece right here. Not only that, but because I now know b and c, I can use that same super important equation, b squared equals a squared minus c squared, in order to solve for the missing piece, which is a. So if I plug these numbers in, I have 2 squared equals a squared minus 3 squared. So 4 equals a squared minus 9. Add that over, and I get a squared to equal 13. And again, I'm not going to finish that because I need a squared. So now I should be able to write my equation out. B was 2, so 2 squared is 4. And then a squared is 13. And there's my equation. Alright, that's all for just the basics of ellipses. If you feel like you need any extra examples, take a look at the book. They've got some good ones in there. Just keep in mind that for today, we're mostly focused on the origin. If you would like to jump ahead, feel free to look it off the origin, but you don't need to. If you want to see an example of a word problem with ellipses, take a look at the next video. It'll be much shorter. I'm just going to do one quick example of a word problem so that you can see how it kind of works. Alright, thanks for watching. See you later.